Why is work done in isobaric processes P-deltative? Imagine pushing a swing at a constant force or filling a balloon with air at a steady pressure. These everyday actions help us understand why work happens when pressure stays the same while volume changes. When a gas expands or compresses at constant pressure, work is involved because the gas pushes against or is pushed by its surroundings. The key idea is that the work equals the pressure multiplied by how much the volume changes. In thermodynamics, work done by a gas during expansion or compression is described by an equation involving the integral of pressure with respect to volume. But when the pressure remains constant, this integral simplifies to just the pressure times the change in volume. So, if the gas expands, the volume increases, and the gas does work on the surroundings. If it compresses, the surroundings do work on the gas. Think of a piston in a cylinder. When the gas inside heats up, it pushes the piston outward, doing work on the outside world. The work done is directly related to how much the piston moves and the pressure pushing against it. This is why the work in an isobaric process is written as P times deltative, where deltative is the difference between the final and initial volume. This relationship is also connected to the first law of thermodynamics, which says that the heat added to the system equals the change in internal energy plus the work done. When the gas heats up at constant pressure, part of the heat increases the temperature, and part of it causes the gas to expand, doing work on the surroundings. You can see this in real life too. When you heat air in a cylinder with a piston, the air expands and pushes the piston outward, doing work. Or think about boiling water in an open pot. The steam pushes against the air at constant atmospheric pressure, expanding and doing work as it takes up more space. On a pressure-volume diagram, an isobaric process is shown as a straight horizontal line because the pressure stays the same. The work done is represented by the area under this line, which is a rectangle with height P and width deltative. This visual makes it clear why the work is simply P times deltative. So, in simple terms, work is done in an isobaric process because the volume changes while the pressure stays steady. The amount of work depends directly on how much the volume changes and the constant pressure pushing or resisting that change. This straightforward relationship helps us understand energy transfer in many real-world systems, from engines to weather phenomena.